The plan is to be here a couple of hours, 3 hours. We want to have a couple breaks to make this relaxed and nice. So we are going to talk about how to use the cloud with Python, how to automate stuff. Most of the talks we have about automating the cloud talks about provisioning resources, how to create new infrastructure. What we want to do today is to talk about operating stuff, how to use the cloud, how to do the management of the cloud automated using a programming language. And in this case, we're talking about Python. This talk is going to be recorded. It's going to be shared. If you need to stand up for a while, if you want to check it out later. And we have a repository in GitLab with this Jupyter notebook, so all the code is available. If you want to download it and tag along, resources. Sorry? Okay. If you want to tag along, there is no problem, but you are going to need a free account, an AWS free account, or an actual account, so you can run the commands. So we're going to start with a brief introduction, just to make sure we are all in the same page. What is cloud computing? Basically, cloud computing, and the saying goes, it's someone else's computer. We are using computing resources, storage resources, and network resources that a public provider is giving us. It's letting us use for a fee. So we don't need to provision themselves. If you ever had the privilege of trying to set up a data center to build the false floor, the ceiling, to mount the racks, to make sure everything is in place, the network cables work, power is not about to get in fire and burn down the place. Well, it is nice. It's nice the first time you do it. You think, well, when I studied this, I didn't expect to be working in civil construction. But the second, the third time, you say, okay, this is too much, I don't want to do it anymore. It's always the same. So it's easier to let someone else do it. At the end, our work, what we want to do is to provide the value to our customer, to our company by doing applications. All this construction, all this setting up of the computing resources, it's a mean to an end. And cloud computing let us avoid to set up, avoid that time, about that effort, and let us concentrate in what we want to do. So what characteristics does cloud computing has? It is remote, it's not next to us. In fact, when we use the cloud, we don't really care where the resources are. We are interested they are in some place of the world. Let's say we want it to be in America, we want it to be in Europe, maybe we want to be in a country, but it doesn't matter if it's in this street or the next street. We don't care about it. We only know it's not here, it's not behind our building. It's virtual, and that's very important. When we ask for a computer, for a virtual machine in a cloud computer, in a cloud provider, we are not expecting someone running about in the AWS data center and setting up a new server. What they are doing is to giving us access to a virtual computer. The same with the cloud, with the network, sorry. There are all the network infrastructure we use, all the VPC we set up, it's virtual. We are not buying real servers, real routers, real anything. What we are doing, it's creating virtual infrastructure, and that let us be very flexible. Everything is self-service. We don't need to talk with someone. What I told you, there is no people running about in the AWS data center setting up infrastructure. That allows them to let us do the work. We go to the console, we use the SDKs, we use the CLIs, and set up the infrastructure ourselves without the need of AWS to have people setting up the infrastructure for us. And that's very important because that lets them be cheap and give us the service in a very good price. It's automated. As this is remote, we are not able to go to the AWS data center and restart the server. We are not able to go to the data center and plug a keyboard, plug a screen, and work directly with the infrastructure. That's something we used to do when we had our own data centers. We sometimes went to the data center and fixed things in real life. No, here everything must be remote, everything must be virtual, everything must be with an API. And that means everything must be controlled via software. And if everything is controlled via software, everything can be automated. We can do everything with software, with a program, and that force us to automate things. If we are doing things manually in the cloud, if we are logging in the console and doing all the stuffs with the keyboard and with the mouse, we are doing it wrong. What we need to do is to automate the operation. We must be sure we are taking advantage of this. When we can automate the operation, we can be elastic. We can provision the resources when we need them and let them go and stop paying for them when we don't. And that's very important because we need to pay for what we use or pay for what we provision. We don't want to pay for things we don't use. We don't want to be paying for a computer, for a network, for a storage that we don't make use of. We want to get the most value for our money, and that means we use everything. We provision only what we need. Okay, so far, any questions about cloud? We're good. Okay, I hope that means we're good. If you have questions, feel free to interrupt me. Just unmute yourselves and we can talk. So the easiest way, the first way we use the cloud when we start is with the console. A web application AWS make for us, and we can click away and do our operation, the creation of our infrastructure, just by clicking everything we need. And it works. It's good for when we are starting, when we have a specific task to do, when we have a new thing to check. But the big problem of the console is it doesn't scale. If we want to do the same thing 100 times, it's not working. If we want to create 100 virtual machines, to do it in the console, it's boring, takes time, it's prone to errors. It's very hard to have a big team, 10 people, and make sure all the 10 do the things we need them to do the same way. It's going to be differences in what they do. So the console even if it's good for specific stuff and for learning and for practicing something, it's not good for normal operations. Normal operations should be automated. So the other options is the command line interface. It works very nice, right? We can, and I have one here, we can always say AWS S3 LS profile. And what we're going to do is to get information for the cloud, from the cloud in an interactive way. We are seeing there my buckets in my personal account. So I remember when I was young and innocent saying who would prefer to do this if we can do it in the console. I can go to the console and say, let me see the buckets I have in my account. Why would I prefer to do it with the command line interface? That it's ugly. I need to remember the commands. Why not to do it in the console? Why not to do it in a graphical way with help, with buttons telling me this is the nicest way to do it? Okay, the big difference is in the command line interface. I can automate stuff. I can have these commands ready and I can use them very quickly. That's the big difference. But I told you, if I'm going to do it just one time, I can do it in the console and works very nice. But if I want to automate stuff, the command line interface works. Okay, but what's the problem with this command line interface? The real problem we have with it is that unless you are very, very good at shell programming, and there is people that it's really, really good in shell programming, it's not easy to add control logic. If commands, branching, conditional branching, make 4 cycles while cycles, it's complex to check if something exists, and if it exists, don't create it, but if it doesn't exist, create it. It's hard in shell. You can do it. I know people that is very good doing it, but it's not easy. Shell programming has its difficulties. There are no debuggers, everything we know. So there is a better option if we want to automate stuff, and it's the software development kits. You can program in any language you want. Well, maybe not any, but a lot of them. JavaScript, PHP, Ruby, Java, Go, Node, C. Your favorite language, right? And what is our favorite language? Python, right? So yes. Anyone has a favorite language that is not Python? Well, we prefer Python. So we can use the SDK for Python in AWS. Good news. AWS, even if it has all of these SDKs, the best one, the main one, the one they update the most, the one they use internally, the one that has more support, that is that has all the new services, it's the Python SDK. It's one clue that it's very special for AWS is that it's the one with name. All of the SDKs are the SDK for Java, SDK for Node, SDK for PHP. The SDK for Python has a name, and it's called Bottom, P-O-T-O. So we can go to the SDK for Python, the Bottom tree, and find all the documentation about it. How can we install this button in our computers or in for our functions. We can use PIP or we can use Conda. You only install button 3. I put an example how to install it. You create a new Conda environment. It gets installed, you activate the new environment, and you install bot3. And that's all you need. If you use PIP, you have Python installed. You create your environment with PM, Python amp, whatever you want. And you do PIP install bot3, and that's it. You get all the packages you need, and that's it. Here is the documentation for the quick start, how to install it, how to configure it. So the first part of our tutorial, and this is very important, how to connect to AWS. And here is a big difference in how we used to do the things before. Before we have perimeter protection, we used to think the best way of protecting ourselves, protect our data and our applications was to have a perimeter, a barrier around everything. And we log into this barrier, and once we pass this gateway, and once we were connected and inside our resources, we could do whatever we want. The big problem with this perimeter protection paradigm is that if you are able to cross the threshold and go inside the resources, being a malicious actor, you can do whatever you want. You can hack away at your leisure. So what we used to do now is zero trust. We don't believe in anyone and anything. Every call to an API to AWS must be authenticated. It doesn't matter if you have just sent 20 API calls. The 21 call has to be authenticated, has to have a cryptographic signature that lets AWS know who you are and which permissions you should have, what could you do. So to make sure we are connected properly to AWS is really, really important. First two rules when we are using Boto to connect to AWS. The first rule is never put your credentials in code. Never put your username, your password, your secret key, or your access key ID in the code, not even encrypted, not even in base 64, not even scrambled. No, never. You should never, never, ever write that code, write that credentials there. Because once, sooner or later, you're going to post this code and share this code, and these credentials are going to be available for a malicious actor to use them. So don't do it. And the second rule is really, really, really don't do it, right? Never put your credentials in the code. And I can tell you that because I have done it, and it's a very bad idea, okay? And please learn from my experience. Don't put the credentials in the code. Okay, perfect. Sounds nice. I won't share my credentials. How to connect anyway? Okay, the first thing you must do is to have a user. We're going to see another way in a minute, but you need to create a user, and this user should have programmatic app access. In the window, in the console where you create the user, you check this programmatic access. So AWS creates an access key. That access key is going to, it helps to the CLI, but also helps with bottom, and we want it for bottom. So when we create this user with some permissions, and we must always try to have the least permissions needed for our work. It's going to give us this access key ID and this secret access key. This works like a username and a password, even if it's not the same thing. But we get these two values. And if we have the CLI installed, that is not needed, but if you have it, you can use the AWS Configure command, use the access key ID here, then the secret access key here. You check the default region and the default output format, and that's it. But if we are doing this for real, we normally don't have only one account. Normally we deal with several accounts. We can even have dozens of accounts. So we need to differentiate it. And the way of doing that is with named profiles. You do an AWS configure with a profile. You put a name you remember for your account. And you put your account, your access key, your secret key, and everything. If you see the difference here, we had a previous value configured. And here we didn't. This is a new profile. That's why it says known, that is our default. That means if we rotate the credentials, you can do this again. It's going to tell you, okay, I have a previous one configured. You put your new data and it works fine. Okay, what if I don't have the CLI installed? I don't want to use it. I want to use Boto. No problem. What you can do is to use these files, .aws credentials, .aws config. In fact, this command over here, what it does is to edit these files in your home directory, by the way. So these credentials and config files is going to store the access keys, the secret keys, the output, and the region. Yes, there is a security risk here. If someone gets access to your computer and someone is able to read these files, it's going to be able to get your access keys and secret keys. So we must be careful with our computers. We have to be careful with these files. Yes, there is malware now that tries to access these files and tries to do something with them. So take that into account. We must be careful with our environments and with our computers when we do this, right? Okay, there is another option. And this works very fine when we have shared computers or we have Lambda functions in the cloud and we don't want to never write the credentials in the code and we don't have these files to store the credentials. And this is to set up environment variables. We can set up these variables, access key ID, AWS secret access key, and AWS session token if we are doing temporary credentials, which is good in some cases. So you set up these variables at the operating system level, and that's it. That's the way you can automate. What is the priority? If I have credentials stored here and stored there, which credentials it's going to use? Okay. When we create the session, and we are going to talk about it, whatever comes in the call to the session object, that's the most important value. But we shouldn't do this one thing as if it's not there. The second one is environment variables. These have priority. And the third option, the third value it's going to take, it's the configuration file. So you say, okay, I'm tired of hearing David. Let's see some code. We are going to use the Boto3 SDK. We just need to do an import. We are going to create clients. For each service, we create a client. So we have bot3.client, and my client is going to use the IAM service. And we're going to use this client to call the get user function. This get user function tells me who am I. And we print the response we got. And that's it. It's as easy as that. Let's take a minute to see our response. Most of the responses we get from Boto have this structure, and this structure is to have a dictionary, and this dictionary has two parts, two fields. The first field is response metadata. It tells us about the response we're getting. It tells me, for example, that the status code was 200. If I'm not connected to the internet or have no access to AWS, instead of having a 200 response, we're going to have a 500 response. If our request has an issue, if we make a mistake in the parameters, here there are no parameters, but if we have a mistake in the parameters, we're going to have a 400 response. If our credentials are incorrect, we're going to have a 403 response, right? Forbidden. It tells me the request ID. This is useful if you need to have some security stuff, what's the name? I forgot the name right now. You have this Cloud Trail. It's a service that gives us all the calls we made to the API, who make the call, what was the response of the call. So we can check what we're doing is appearing in Cloud Trail and make sure everyone is using AWS properly, who access which stuff. If it was needed to retry the command because we have problems in the network or AWS has issues. And we have some headers. What is the response, the length of the response, when the request was done, the request ID, you see is the same one. This response metadata is going to appear in almost, but not all, the calls we do to the API with Poto. And we're going to have the data of the response. This is the part we are interested in. It tells me the unique resource notation for my user. It's saying you are using this user in this account. It tells the date and time of the request. Sorry, date and time of the creation of this user in UTC, in Greenwich time. The path, if we are using paths in EIM, it gives us the tags, the extra information we put in this user, the user ID, and the username. And looks very nice, right? Okay, remember what I told you about the profiles? We are not just using one account. We use a lot of accounts. How do I control the accounts with profiles? And we can use profiles by using sessions. Up here, we're using the default session. When we use Boto to create, Boto3 to create the clients, what we are doing is to use the default session. I would recommend you not to do that, not to use the default session. Always use a profile. How do we use profiles? We create a session object. Boto3 session, you use the profile name. This profile name is going to take the information from the credentials file over here.
Quick question, David.
Yes.
When you're creating the profile session via Boto3, is that the same backend mechanism that when you're creating the profile, like when you go into the CLI and do AWS Configure and then create it under a session name, is it using the same backend mechanism for that as well?
Yes and no. Here, we are not creating the profile. The profile should exist.
Right, right. But you're calling it, is it this, are you calling to the same identity as when you
Yes.
create a configuration file?
In fact, it's reading from the configuration file. When I
Perfect.
do
Okay,
this,
awesome.
yes, when I do this, it's going to look for the data in the configuration file and in the credentials file
Wonderful.
for this one. And
Okay.
we can set up the region. I must tell you, I recommend you very much to set up the region because it's easy to forget it and it's easy to it's going to use this default region if you don't say anything.
From the config file. Okay,
Yes.
so if you call it in the okay, got it. Cool. All right, thank you. Appreciate it.
Yes, so it's better to to be explicit, right? Sen of
Right.
Python. It's better to be explicit than implicit. So I would tell you, put the region here so you are sure. Very important stuff if you are using several regions that it happens, you would need to open several sessions. Session for US West 2, session for US East 1, session for US Central 1, one session for each region, right? If you need to connect to several accounts at the same time with several users, you need a session for each account, for each user. So once we create this session, we use it to create the IAM client, and we can get the username. It's the same stuff. The only thing we need to do is to create this session object. And here we have our username. Normally, this is the way we use the responses. Instead of printing all the response, we only go for the user field, and the user field, which is a dictionary, we need the username field, and that's it, right? So you're going to be a lot of these things. Response, we need this field, and we need this field within this dictionary. There was something, okay. Something very important I need to tell you. Remember the zero trust. What happens if my session has incorrect credentials? It's going to fail in this code? No, it's not going to fail here. When you create a session, you are not doing anything. You are not calling the AWS API. It's not checking the access key and the secret key here, because you are not actually doing anything. It's going to fail here? No, it's not going to fail there either, because you are creating the client, but you are not connecting yet to AWS. The error is going to show here, because this is the first time you call AWS APIs. So this is zero trust. Unless you try to connect to AWS by doing some function, to calling one method of the API, you are not actually connecting. You are not opening connections here like a database. When you open the connection and then start sending a lot of commands on that connection, no, you are creating a connection here. And this is the place where the error is going to happen, if the credentials are wrong or the network is not working. And each time you do this, each time you call an API method, you are sending the credentials again, so to speak. Okay. This is another example how we can use the different fields, right? We can format the responses. What we have here is a JSON object, right? We can use it as any other JSON object. And very important, the tags. These tags over here, it's a list of dictionaries. So we can use list comprehension to work with the tags, right? For each tag we have, we want to print the tag and the value. So an extra tip, something I want to add here that helps a lot. We have our bosses, and our boss tell us, I want a report of all the users, and I want to know when they were created. I want to know the name of the user. I want to know which department the user is in. So we get our forms when they, or emails when they give us the information of each user, and start collecting all the data and write them in a document. That's manual. That doesn't scale. If I have 1,000 users, 10,000 users, that's going to take me a long time. It's going to be a nightmare because I'm going to need a lot of time to get all the forms and get all the emails. It's going to be hard, right? It's not going to be easy. Okay, I can have a database when I have the users. Okay, but I have the information in two places. I have the database and I have the actual accounts in AWS. So how do I make sure they match? Everything I gave a record in AWS exists in the database. I cannot be sure. It's prone to errors. The nice thing in AWS is these tags. These tags, it's like an internal database. It's a database they give to me for free that I can use. So when I create the users, I should have a tag for every piece of data I will need for a report. If you have this form to create a new user, and when someone asks for a user, they say, this is the name, this is the email, this is the department, this is the internal user name, number, everything. You can write it in tags. You can create a tag for each of those fields. And when they ask you for the report, you can make a program that reads the users, reads the tags, and use the tags to fill up this report. Use these tags to get all the information you need. And that makes things really, really easy. And that works not only for users, it works for virtual computers, it works for Lambda function, it works for DynamoDB tables, it works for elastic balancers, elastic load balancers. Everything you create. Give me a second, the sun is playing tricks on me right now. Let me see, yeah, that's better. You can write all these tags, and then you can create programs in Boto, and you can use these list comprehensions to have all the information at your hands. You are sure all the users have the information you need for the reports, all the virtual computers have all the information you need for the reports, and you can get it out fast and easy. So this is an extra tip again to give to you. So nice, we have connected and we are able to get information from AWS. There is another way. There is not only accounts, users, sorry, for doing this with access keys and secret keys. We can use roles. Role is a very important thing in AWS. It's something we must master. We can get a lot of use of roles. Roles have to do with temporary credentials, and I have my role here for AWS. So the idea is we can give permissions to a user, and that means we have the ability of do something as persons. It's intrinsic to us. When I log into AWS with my account, I have permissions that doesn't change. A role is a set of permissions that I can assume, I can get when I need them. And if we create a nice framework for permissions, what it's going to happen is that me, David, maybe I have permissions to check things. I have read-only permissions. I can see the information in AWS, but I don't have permission to change things. But because changing is always a most delicate situation. Maybe I'm deleting something that should not be deleted, or I'm creating something that it's going to have a cost. So it's better to be careful with that. It's better to have an extra step of protection. So what I can do is to create a role, and this role is Shiva, the destroyer of worlds, and I can destroy databases, destroy resources, and I can assume the role. I can have this role that lets me do potentially destructive things, and I can put it when I need it, use it, and then remove it. That way, if I try to do something destructive by mistake, I won't be able to, because I don't have the role in that moment. So it works nice to be careful when we are working in production with real data, with real infrastructure. So we're going to work with roles. We're going to create a role. We can create a role in the console. You go to IAM and you go to the web application and you do whatever you need to do. But we're talking about Boto, right? We're going to do it not by the console. I'll show you where it is. We're going to do it with Boto. We have consulted information, or now we're going to create something. So we have IAM, and we have role here. These are the roles that exist in my account right now. First of all, we're going to create this policy document. It says, who can assume this role? Who is going to be able to use this helmet? Because I don't want anyone to get this role. And we're saying only instances can have this role. That is very nice for the roles. It's not only users that can get the role. I can give the role to an instance. I can give a role to a Lambda function. I can give I can give the role to a service, right? I can give permission to a computer to get the role. And we're going to check how nice is that in a minute. So this says that even if someone can get their hands in this role, it's not going to be able to use it because only instances can use this role. We check the role. Okay, this is our dictionary. I need a new session, right? Because the session I created before, the PWC 2021 session, it doesn't have the needed permissions. I need to create a session with my credentials because we are creating roles and users. So I create a session with my profile. I create a new client for IAM. And we create the role. It's going to have this name, the policy document we had over there, the description, and the tags, right? We execute that, and as easy as that, I don't see the role. Ah, here it is, easy to read only role. And we're going to check that in a minute, that it took a little bit of time to answer me. Okay, the role is created. We have a response And the response, as always, has the metadata, and it says, okay, everything went okay. And it gives me the information of a role we have just created, right? It was created right now. And it says, okay, it exists. And this is our role name. We're going to create an instance profile for this role, something that the instances can use. If you do this in the console, you don't need to do this step. This step is doing automatically for you. But if you're doing it with Boto, you create the instance profile, 200, everything went okay. This is the instance profile ID, the name. And then we can add a policy, which permissions this role has. Because if I check this role, it doesn't have any permissions. So we're going to give it permission to do read-only access only for EC2. We execute that, we have a 200 response. If you check, there is no data response. We only have the response metadata that says everything went okay. So if we check our role again, we're going to have the permissions. As you can see, everything we can do in the console, we are doing it right now with Boto. And we assign the role to the profile of the instance. It's something you don't need if you do it in the console. 200, everything good. And then we can associate this role with this instance. What does it mean? We have an instance here, 32E, is this one, 32E. And this instance, if I go to the security tab, doesn't have a role, right? What does that mean, the role? Okay. No, it's not that. Give me a second. And this is very interesting. I'm connected here to the instance, right? This instance has Python 3 installed, right? And it has Boto installed. We have already done that. Right? We have Boto installed here. And I have a small program here. List instances. And this program imports Boto 3, creates a session for this region, creates a client for EC2, describe instances. I want to know what instances exist. And don't worry about this. We're going to see this in detail. It's going to give me the information of the instances. So if I do Python 3 and then list instances py, it tells me, no, you have a problem. It doesn't work. You don't have credentials. What does it mean I doesn't have credentials? I don't have the .aws directory, remember? If I use AWS S3 LS, it tells me you don't have credentials. You haven't initialized the CLI, right? I would need to do AWS Configure first and put my access key ID and my secret key. But I don't want to do that. I don't want to add an access key and a secret key. Why? Because this computer is shared. I don't know who is going to enter here. So I don't want to set up these values. What option do I have? I have the option of the role. The role is going to give me temporary credentials. How? Okay, first thing first. First thing is I need to add a role to the instance. And we're going to do that here. Associate the instance profile to this instance profile to this instance. Perfect. And that means that if I reload the instance information, it's going to tell me it now has a role. That means I give permissions to this instance. Even if I got access to this instance, I can use this role to make calls to AWS, but I can take the credentials from here. And that's very important. I will run the program again. And now it works. It works because I give permissions to the instance, not credentials. I didn't add an access key and a secret key ID. Sorry, an access key ID and a secret key. What I did is to give permissions to the instance itself. So this instance can do anything it has permissions to. And it takes some time, right? Here it is. EC2 read only. What that means is I can do this AWS EC2 instance. It works because US. Why does it complain about this? As it doesn't have a config file, I don't have the .aws directory, remember? It doesn't know what region to use. I need to be specific about it. You see, it works. I can get the instance information. But if I try to do something else, I don't have permissions because I only give permissions to EC2, to the EC2 service. So I don't have permissions for S3, for example. But now I don't need the AWS directory. It doesn't exist. There are no access key, secret key I can install. Even if I got access to this instance, there are no credentials for me to extract and to use. And that is very useful when we want to be very secure in what we do, right?
A quick
That's
question.
Yes.
I thought that you had specified the region in your session call. Was that a previous one and not the one that you passed in?
This region, right? US West 2.
Right, but remember, you ran it a second ago, and it coughed. It failed because it said the region wasn't specified, and then you right, exactly. In the initial call in Jupyter Notebook, I thought you had this. I thought you had the region specified.
Yes, and yes.
So why did it fail?
Okay. Here I am creating the. I am creating the session,
right,
in Boto with US West 2. So I'm being explicit about the region.
Okay.
When I use the CLI here, the CLI is not Boto, doesn't have the session.
Gotcha.
I'm
okay,
doing here directly, right? As I'm doing it directly, it tried to go to the .aws config file, but it doesn't exist. So it doesn't know the region.
Okay, thanks. That makes sense.
And just to be explicit, my list instances creates the session, but it doesn't specify a profile, right?
Right.
Because there are no profiles here. There is no configuration file.
Right. Exactly.
So any profile you put here is going to fail because it doesn't exist. We are using the default profile that doesn't exist either. So we need to set up the region name explicitly. If not, it's going to make this error to this program. So we need to make sure the region exists. So I would tell you, especially in very sensitive, security sensitive environments, if you have a production account and you deal with personal data, the use of roles is really recommended. It's much better because it makes hackers cry in night because they have no credentials to extract. These roles also are needed for Lambda functions. A Lambda function is a function as a service that AWS has. They need roles to know which permissions they have. What can they do? And we want to make hackers cry. Yes, Chris, we want to make them cry. Let's say they need challenges. Hackers tend to be guys that like challenges. Our work is to make things challenging for them, and their work is to make things challenging for us. It's a nice synergy between us. Okay, you say, David, I love this. It's very nice, but it's a mess. I want to create, I want to assign a role to an instance, and I have to do this, and then 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 to do this. And finally, to assign the role, it's like half a dozen steps. It's hard. If I forget to do one of these things, nothing works. I think your talk was the easy way to the cloud, and this doesn't seem that easy. I think it's easier to do it here in the console. Okay, you're right. The first time it is maybe complex. I could tell, well, it's not that easy. But, and this is the important thing, we can automate stuff, right? All of these steps we do, we can create a function, grant role to instance, and we can say, I'm going to pass you the session object. I'm going to tell you which instance. I'm going to tell you what name I want the role to have. I'm going to create a new role. I want the description for that role, and I want the policy the role is going to have. And everything is here. Everything we did is here in this function. Instead of running it one step at a time, we're going to do everything at once. One thing only. I want to stop here for a minute. I wait 10 seconds. Why? Remember, I created the role and it doesn't show up immediately. We need to remember AWS is asynchronous. When you create something, when you ask for something, when you change something, it's very common for AWS to return the response before the change is made, before the resource is created. AWS tends to say, yes, okay, I got your request, I'm going to do it, but it's not completely done yet. And the name for it is Eventual Consistency. Things are going to be consistent eventually, at one point in the future. So if you don't add this sleep here, when you try to assign the profile, it fails because it tells you the profile doesn't exist. Even if the profile was created here, and even if you have used the profile already, for EC2, the profile takes 5 to 7 seconds to be created. It's not to be created, to be available for AWS, the EC2 service, to notice it. So we need to wait. We need to give it some time so it can use the profile. That happens a lot in AWS. And you saw it here, and it happens to the console. The console, we need to know it's doing API calls in the background. Behind this screen, it's using the same stuff we are using, the API calls. So the problems we have here is the problems we have in bottom. That it takes time. It's not immediate, the changes. Okay, let's try it. I'm going to assign to this instance a new function role. Create via function, and we're going to give it this policy. So I execute it. And if in the future I need to give permissions to the instances via roles, I only need to run this function and it's going to do everything. Boom, like that, automatically. I need to assign permissions to a security group. I need to generate a report. I need to do anything we want. We can create functions that do anything we need. So if I reload this and I check this, here is our function role. So it was created just now. It gives the permissions we wanted. It should be here, and it assign it to the instance like that. Easier than doing it in the console. I would have to create the role, assign the permissions, and then go to the instances and go to security and modify the EIM role. Instead of doing all those clicks, all those steps in which I could make a mistake in any of them, I can create a function and use this function to do all of that in one go. I only need to change which instance, I only need to change the name, I only need to change the policy, and that's it. That's what we want to do with this. Okay, David, what I didn't like was this sleep part. How do I know 10 seconds? Well, in this case, it was trial and error. Okay, there are a function AWS gives us for that, and these methods are called waiters. Waiters wait for a resource to be available, created or usable. So we say to our program, wait until this happens. Waiters are, when I use them in several places because, as I told you, AWS is asynchronous. You say, create a rule in CloudFront, and it's going to take even minutes to create that rule. So you put this waiter, and the waiter is going to be there until the resource is created, so you can start assigning the values to the rule. Or if you create an instance, you can put a waiter to say, wait until the instance is finished, and until the instance is ready, you don't do anything, right? For example, you can create a waiter and say, I want a waiter for the instance profile to exist, and then wait for this instance profile, try every X seconds. For default, what this function is going to do is to make a call every second, 40 times, 40 seconds. And if in 40 seconds it doesn't say the profile is ready, it's going to return an error. But you can change that. You can say, okay, check every 5 seconds and try 200 times. I can wait a lot of time. The bad news is not always works. In this case, when you try to do this instead of the sleep 10, it tells you the profile exists, and in fact it exists because this call would fail if the instance was not available. But this other service, EC2, that's a different service, cannot use the profile yet. So even if you put this waiter in this code, it doesn't work. So that's a problem. Not always the waiters work as you would expect them to, but most of the time, yes, most of the time a waiter is what you need. And this is the way of using it. Every service has its own waiters. It's not like there are the waiter, whatever you want. No. If I go to check the IAM service, check, here it is, the IMS service reference of Toto3. I have the waiters here, right? I have the client with all the information we need about the client. And we have the waiters here. And we have 4 waiters. I want to check the instance profile exists. I want to check the policy exists. I want to check the role exists. I want to wait for the user to exist. So these are the waiters we can use, right? So remember, if you need to wait for something to be created or to be available, you can always use a waiter. So the summary of how to connect to AWS with Boto, the best way is using roles. So the hackers grab. Temporary credentials are hard to steal. Even if you could steal it, they only work for some time. You can put conditions here. Only EC2 instances can use this role. Even if you steal the credentials, it doesn't work because you are not instance. And if you need access keys, you can store it in the files. Even if you don't have the CLI installed, you can create the files by hand and they work. Or you can use environment variables, and you should never, never, ever store the credentials in code, right? Because they are going to leak. Someone is going to find them, and that's going to be a mess. And I know it because I have done it. So never store credentials in code. Okay. Let's take 5 minutes. Check a coffee or something, and we get back to continue with the talk.
Awesome.
Questions? If you have questions, right now it's a good time.
Perfect. Anybody have any questions for David?
I have a question about waiters.
Right.
Yep. I'm just wondering how reliable do you find them? It sounds like it didn't work in this particular example. Are they actually worth using, or is it something that the Bodo project built to try and as an alternative to like putting a sleep in your code, but it's not working so great?
We have to understand something, and this is a problem that AWS has in general. It's not particular to Boto3. And the problem is each team, each service has its own 2-pizza team. So the services are really independent between them. So the waiter, in this case, let's talk about this case. The waiter is part of the EIM service. So it works great within the EM service. If the call over here would be a IAM call, they would work perfectly. The issue is that we are using the EC2 service, and that's a different service. So the waiter works for IAM, but not for EC2. That's the big issue. And that happens in the console too. If you create a profile and really, really quickly try to assign it to an EC2 instance, you don't find the profile. As you are doing it manually, and this takes between 5 and 7 seconds, normally you don't notice it because in the time you take to click the buttons and assign the profile appears. But when you automate this and make the program, it is very evident. You're trying to do this and fails and fails and fails. And you say, I don't understand why, because when I try to do it the second time, it works fine. In fact, when we do it in steps, we don't notice the problem because it happened. We took 7 seconds from here to here, right? So you say, okay, that means waiters are not as useful as should be, right? What I would tell you, if the waiter exists, because as we see, there are not an infinite number of waiters, there are some waiters. If the waiter exists and the waiter works, use it. It's better. It does the work for you. You only need to say, I want to check every 3 seconds. I want to check 100 times, and that's it. We can go with the rest of our program. But sometimes the waiter doesn't exist. Sometimes the waiter doesn't work as expected. In that case, you need to add a sleep and wait for some time. I will give you a second example. WAF, Web Application Firewall. I have a program that creates rules for WAF. There are no waiters. There doesn't exist. These waiters, they are not there. I cannot use them. I would love to use them, but they are not there. But I didn't want to make a sleep because the time is very variable. Sometimes I create a rule and it is ready in 5 seconds, and sometimes it takes 5 minutes. It changes a lot, the time I need to the response. So what I did is to, what it says here, right? Calls the get instance profile and check if the result is correct. I did that. I create the rule in WAF and I poll. Does the rule exist? No, it doesn't exist. Okay, wait 5 seconds. Does the rule exist? No, it doesn't exist. Okay, wait 5 seconds. And it starts doing that. 5 seconds, 5 seconds, 5 seconds until it says, okay, the rule exists, and then I proceed to the rest of the program. So I created my own waiter, right? Instead of using the one Boto has, I create mine, and that's it. I have a function that is wait for this rule to exist, and it does its things until the role is available, and then I proceed with the program. But if I would have the option to use the waiter Boto has included that it doesn't exist in that case, it's better to use the one that someone built for you, right? So, summary, if the waiter exists and works, use it, no problem. If the waiter doesn't exist and doesn't work for you, you would need to do your own waiter, or you need to put a sleep for some seconds if the time is more or less specific, and that's it.
Okay, thank you.
Perfect. Thanks, Tim. Any other questions for? Oh, there we go. Go for it now.
Oh, sorry. I just wanted to say thank you to David for the wonderful presentation.
Thank you. Thank you. I hope you like it and the rest of it. Okay.
Yes, I did.
I'll be back in a minute.
Okay. For those on LoudSwarm, you'll see the slideshow, but we'll be back in about 5 minutes. Thank you. Just pass it right on to David. Any questions? Just want to make sure that if you have any questions, that we get those answered before we get going again. Take a look right here in the Slido, just to double check. I think we should be good to go, David.
Perfect. So when we work in the cloud, we should be ready to work with a lot of data. Not always we're going to work in our personal accounts with 3 instances. Normally, we're going to have a couple hundred instances in each of our accounts. We're going to have tens, hundreds of users, tens, hundreds of Lambda functions, 10 or thousands or of buckets, files, databases, a lot of information. So if we want to get information of all of it in one go, it will take too much time. It will take too much resources. It's going to be hard. So we must be ready in our programs to work with chunks of data, not to get all the information of all the instances, but to get chunks of instances. Only 50, only 100 instances in one go. For example, if I want the information of my instances, we can create a client for EC2. I want to get all the information. And what we're going to have is the reservations information, an array, and the response metadata, the dictionary we are used to that has the 200 OK and everything else. Okay, how much information has the reservation array has? 3 records. Why 3? 1, 2, 3, right? Are the 3 instances in my account. Okay, let's see the first reservation. The first reservation is a dictionary, and it has the reservation ID, the owner, that is the account, and an array of instances. What does that mean? That we have 3 reservations, and each reservation has 1 instance inside. So if I want the information of the instance, I need to go inside the reservation in the instances array. So I want to check the first instance. And I finally got the information about my instance. The instance ID, for example, the name of the key, the image ID, the number of CPUs, the IP address, the root device, security checks, the tags, everything. I have all the information here. But I need to do all of this. Check each reservation and check each instance which within that reservation. So it's step, step, step. Okay. If I want to check the tags of it, tags is another array inside. So you need to do first reservation, first instance, first tag. And we have it here. We have 2 tags. First tag is color, second tag is name. Okay, it looks complex. It looks like you need to traverse a lot of that structures to get the information you need. But you can do it easily. How? Using for loops. So we say for each reservation in the reservations array, for each instance in the instances array, I want to get the tags, and the way to check the tags is with list comprehension. For each tag in the instance tag array, if the tag is color, because I am only interested in the color tag, print instance ID and prints the value of the tag. So we run this, and as easy as that, I have the information of my 3 instances and the color of each instance, right? Red, red, blue, red, red, blue. And I can do that with only 3 lines of code. Right now, as a sample, well, I'm printing the color of the instances, but in real life, I can have here all the tags I want. And this report, my boss asked for me, give me of the 1,000 instances, who asked for them, what is the application it is used for, when was it created, how much hard disk does each instance has. We can get it quickly from this information, from the basic information here and the tags. We can get that report in a matter of minutes. And I have a program that generates that report daily at the morning if I want. Each morning I want to run this program. It's going to give me the updated inventory, and I can use it for whatever reason, whatever purpose I want. And it's really, really easy, really, really fast. It's very consistent. I am sure that all instances are here, that all the data is updated, because it's the real data that exists here. Okay, nice, but that works fine with a small number of instances. If we have a very big number of instances, it doesn't work as well. Okay, first option we have, we can filter the queries. It's not needed. When I do the describe instances here, I don't pass any parameters. That means it's give me all the instances. In fact, they are not all, but it's all of them. We can filter them. We can say, give me the information of the instances, but only these ones. And this is a list. I can put several instance IDs here. So it's not going to bring me all the information of all the instances. It's going to give me the information only of this instance. Right? And I have everything here.
It's really important.
Sorry? Okay. Not only instance ID, I can select by other fields. For example, I can ask for instances which security group is equal to Bastion. So what I have here is only the instance that has a security group. Okay, here it is, network interfaces, security group, Bastion. Right? So if my boss asks me, hey, which instances have this security group, that it's the security group that give access to external parties, or the security group that access some database, it's as easy as this to have that list, which instances have that, instead of trying to go one by one here. Or we can select by tag, and that's very useful because, as we talked earlier, we can use the tags to store all the information we need, the particular information we need. So when we use these tags, we can say I want to select only the blue instances, right? So it's only going to bring me this one. The tag syntax for the filter is a little bit different, because you put tag, colon, and then the key of the tag. And in values is the value of the key. So I run this, and I got the instance which has a tag blue, right? So we can filter the instance and get only the instance we want. But if there is too much data, as we told about, it's not a good idea to bring everything at once. If we have thousands of instances, this is going to have a problem in memory. It's going to take too much time. For example, I only have 3 instances here, so it's very small, but I have a lot of policies, right? We have all of these policies, 800 policies. What happens if I say, bring me all the policies? even if they are not attached. Max items 10. Check these parameters. Is truncated? True. What it's answering me is this is not the complete list. There are stuff missing. And if I print all the policies I got in response, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 policies because I only asked for 10 of them. So it's telling me I bring you the 10 you asked for, and these are not all of them. Right? But as part of the response, we got the next marker. And I think it's not doing what I want. Have a problem here. Let me remove the max items, right? Truncated true, marker. It bring me 100. I think I was okay. Let me, I think 10 items. Let me run it again. Yes, my mistake. I was confused. It brings me 10 results. And this is what I didn't see the last time. It's truncated true. And this is the marker. This marker works for the pagination. It's telling me if you want to check the next 10 policies, use this marker. So I take the marker, I put it here in next marker. And when I run this command, it's the same one, but I added this parameter, marker. So I'm telling it, bring me the same policies, but don't start the beginning. Start with the 11 policies. So if you check, these policies are different than these ones. And I set up the next marker. If you check the marker, it's different. This ends in SG, this ends in HTW. So if I run this again, I get different values. It's the third page, and this changes. So I can keep running this command and bringing blocks of 10 policies. I am paginating. Right? What this brings me, the ability of doing this pagination. Each call is very fast. I'm only bringing the next 10, the next 10, the next 10. The memory consumption is less. I do not need to store the 800 responses of policies. I bring only 10, I process these 10, and I go for the next 10. So this report my boss asked for me, I want to check all the policies and what they have. I can do a program that is doing this pagination. It's doing the bring the next, the next, the next, the next. And my program doesn't need too much memory. It doesn't saturate the network. I can put a nice progress bar to say how it's progressing. Everything, very nice. And as you see, it's very easy. The only thing you need to do is to save the marker and pass the marker in the consequent calls. And to know if you finished, is this is truncated. Let me do something just to confirm. Let's say we want 400 items. Let me take this out. So I say I want 400 items. Notice it takes longer. It's truncated. I say here 400 items. The second call takes some time. It printed the 400 items. Let me take this out. And the third call, as we saw, we have 801. It should be one remaining. No, let me give. It should be one more policy. So the third call, something wrong. Marker. Okay. This is my mistake. The third call is truncated, is false. It says we finished, but it doesn't exist the marker because it finished. So there are no marker values. That's what it failed, right? But as you see, we finished in the third call, and that's what we want. Okay, we can do this. We can create a while loop that says while it's truncated, call the next page, call the next page, call the next page. But Photo3 has already helped us with it, and it's called paginators. The same way we have waiters, each service has its own paginators. And the paginators do all of this for us. They check the next page, check the next page, check the next page. For example, we have a paginator that is called list policies. It should be here. Here's the documentation. You create the paginator, and then you check which policies you want. You can filter everything we saw in filters. I only want the red instances. You can do it here. So we say we want a paginator for policies. This name normally is the name of the normal method. If the method we use is list policies, that is the name of the paginator we need, list policies. And we want to paginate and the parameters of that method. So the parameters we have, the scope only attached, policy usage, are this scope only attached, policy usage. But we can configure the paginator. We can say, I want at most 1,000 items. If there are more than 1,000, stop paginating. Bring me only the first 1,000. But each page, only 3 values. I only want 3 each page. So we create the paginator. And then we say for each page, print the page. So the first page tells me is truncated. There are more values. And these are the policies that exist. 1, 2, 3. Remember, 3 policies per page. And the response metadata. This is the second page. Second page says, okay, there are more values. 1, 2, 3. This is the third page. There are more values. 1, 2, 3. And this is the fourth page. It's not truncated. This is the last of it. And it only has 1 policy. No, sorry, 2 policies. 1 or 2. And that's it. Hey, David, why 11? Because I say I only want attached policies. So if I go here and say, give me only attached policies, these are the 11 policies. 3, 3, 3, and 2. 9 and 2, 11. These are the 11 policies it brings me here in pages of 3, and the last one is 2. Okay, but I don't want to see page and page and page. As easy as this. For each page, for each policy in each page, give me the name of the policy. That's it. Hey, David, they should be 11, right? Why doesn't it, why only 2? Why it only show 2 policies when I do this? Someone has any idea why when I run this, it only shows 2 instead of showing me the 11? As you remember, we're using paginators, and with the paginators, we're getting only the next page. Right now, we are in the last page. Remember, 3, 3, 3, and 2 at the end. Well, these are the 2. If I want to check all the policies, I need to initialize the paginator again. I need to run this cell. So I run this cell. The paginator is starting at the beginning. And if I run here, it's going to bring the 4 pages and the 11 policies, right? And that's it. So remember, the paginators is bringing us the next page, next page, next page. And when they finish, they're going to keep bringing us the last page. So you need to reinitialize it if you want to get all the results. So the good thing about the paginators is they do all that work for us. All the next bring the next page and the next page and the next page. All of it, it's integrated with the paginators. And that is very good for us. So, questions about paginators? As we saw, there are a lot of them. Each service has its own paginators. If I go to the EC2 paginators, we want to work with the instances, for example. Taking some time and showing me the paginators. You can hear me, right? I'm getting worried for my network.
Yeah, no, you're good.
Perfect. It's not working. I don't know why. We're going to do it manually. Paginators, paginators, paginators. I don't know why. Here they are. This is the paginators for the EC2 service. So if I want to check the information, the describe instances, this is the documentation for that, right? We want to describe instances, and there we have the filters and the instance IDs, everything we saw when we talk about getting instance data. So we can automate everything. And this is something I love. This is the nice part of the workshop. We get a client for CloudWatch, and let's do it the nice way. I open CloudWatch, and I bring the metrics for the instances, for example. Check metrics. We check instances. And I want to see the, let's see, CPU utilization of one instance. CPU. Here it is, CPU utilization for the last hour. of this instance. Okay. Okay, it doesn't look very interesting. Let's check another value. Network packets in, network packets out. In the last 2 hours in my local time zone, because I want to check it in Mexico City time. There it is. And I want the title over here. Period to be 1 minute. It's the same, it doesn't change. I want to add the line. In short, I want to edit this this graph, right? I want to add an horizontal annotation that says normal, let's say level. We want it at 10,000. I always forget to save this. Looks nice, no? I would prefer to have a maximum limit of 20,000. So I have created here my graph, right? It looks very nice. Let me hide this. Looks great, right? Okay, my boss wants this every day. They want me to generate this graph every day, and they want this graph for all the instances we have. So one option is for me to do this graph and then change the metric to change for each instance, and then do a copy paste, screenshot, and send this information. Sounds like something I would love to automate, but how can I automate this? How can I automate the generation of a CloudWatch graph? Okay, is this tab. This tab that sometimes we ignore. Source is for it. And we have image API. So you go here, you go for the image API, and it gives you this JSON object. It tells you which metric you are using. It's telling you the name, the title over here. It's telling you the 5 minutes period. It's telling you you use this warning level line over here. It's telling you the limit of the axis that you want the last 2 hours, all of it, right? The time zone, I want it in Mexico City time, everything. So I copy this one and I go here. Cadena widget, I'm going to remove all of this, the JSON object, and put the new one. I need to move it over here, and I need to put quotes around all of it. As it uses double quotes, I need to use single quotes. So we do this. Second. The good thing about this, put the JSON object here is that you only need to do it once. And after you do it, it stays like that. If you notice, what I'm doing is to construct a very long string. But at the end of things, this is a very, very big string. String. And that's it. There it is, finished. So I have this cadena widget that it's a very big string, and I'm going to call the get metric widget image with this cadena, right? With this string. So I run this. It has finished. I don't see anything. Okay, let me see this response. What does it have in the metric widget image? Sounds promising. Okay, it brings a lot of values, but I don't know what the hell this is. Okay, I don't know. PNG, it sounds like an image. What happens if I do a import image and let me show this image? Nice, isn't it?
Yeah.
I can get the image I constructed in CloudWatch. But if you remember, this is a string. In real life, this is a string. I can change this string. I can say, okay, the size, I want the size to be different. I want only 500 by 250. And I want to talk about a different instance. I want this instance instead. So I put the new instance here. And I don't like this title. I want to put CPU. Whatever I want. So I run this. I display the image. And there it is. It's not CPU, right? It's network. Sorry, my bad. Network. There it is. Hey, and what happens if I say the script, give me all the instances, and for each instance, I want to get the graph. Okay, let's take this string. Let's put the string here. Check the instance ID is going to be there. So we have this value, right? This variable, that is the instance ID. And we're going to put it here. So we have this plus the instance ID value. And we want the network level for have here plus instance ID. And we want the graph to be a little bit bigger because if not, it's very small. And instead of showing it, we get the value for each one. Let me move this a little bit here. There it is. We're going to take the result and we're going to save it to a file, right? PNG file. We're going to write it using the instance ID as the name of the file. So let's hope it works. Doesn't work. Metric widget has a bad JSON content. Something is wrong here. What did I do wrong? Yes. Ah, okay. Yeah, here it is. This is one. No, give me a second. I think I put this one. Okay, here I need to substitute this with this should do the trick. Okay, let's check. It's my mistake. Not begin first. Okay, this is just a matter to get the string right. And it's done. And the result is I should have 3 files here. Each one with the graph for the different instance, right? So if they ask me to generate these graphs for each of the 100 instances every day in the morning, I can do this small program. That's it. I can generate these graphs. And as you can see, it's as easy as to generate them in CloudWatch. Go to the source part, image API, copy this string, substitute the parts of the string we need. And that's it. We can generate all the graphs we want. So, questions so far?
Anybody who's not in the Zoom, if you have any questions, please put them over there on the Slido on the right side. I'll be able to ask David.
No questions from me, David, but this is really good stuff. This is exactly what I hoped it would be. Thank you.
Perfect. I'm glad. So,
no questions from me either. But I really enjoyed it.
perfect. Okay. Two good news. There are two good news here. First good news is maybe you don't use AWS, you use Google Cloud, you use Netlify, or you use Azure. Sorry for that, but this thing, this ability of automating stuff with Python, it not only exists in AWS. Poto, it's very nice. Poto, it works fine, but it's not the only one there is. All of these clouds have SDKs. All of these clouds support Python, and you can do more or less the same stuff in all of these clouds. So that's great. What we learned to do here, we can do it in other clouds with more or less capabilities. AWS is maybe the one with more capabilities, but all of them support it, and all of them works more or less the same. Second thing is, you tell me maybe I work with Lambdas, maybe I work with a lot of RTS databases, maybe I work a lot with DynamoDB. Everything we saw here, how to connect, how to get data, how to paginate, how to wait for stuff, is the same. The only thing that changes is the specific syntax. All of it you can get from the documentation. To tell you the truth, it's not like I know this from heart. What I do is to have this page open, and when I need to get all the lambdas there are, the only thing I need to do is to go to the documentation, look for the Lambda service, and I know it's going to be a client, and this client is going to have all the methods I need. right? And I know that it's going to be paginators to make the pagination of the request. And I know that it's going to be waiters that let me wait for something to complete before I go to the next one. It's the same for all the services. With the small differences, yes, but it's more or less the same. It's easy once you get the hang of it.
Wait, you mean to tell me you don't have all of this memorized?
No, I have tried, but no, I have to confess it. I don't know all of it of heart. And it's weird, but something I love about the cloud is the speed of innovation. So you work a lot with the service, and when you have it dominated, they create something new. And everything changes. You need to learn something new all the time, and that's something I love about the cloud. You're never finished with it. Okay. So here we have the reference to the documentation. And there is something else I want to talk to you about. We are not going to do it all by heart because we don't have time. But AWS created something new that is called the Cdk Cloud Development Kit. What we saw with Poto, you could create infrastructure with it. And I will tell you the truth. One of the first things I did with Poto was to create a program that took some data, took some tabular data about name of the instance, type of the instance, IAM to use, security group to use, and it created all the instances I needed. So they give me this list of, we need these 20 instances with these characteristics. I put it in this tabular format, and I make my Boto program that read from that file and started to create all the instances. And I was very proud of that program. It worked very fine. It automated the creation of the infrastructure for us. And it was a mistake. It was not a good idea. Why? Because the good idea in AWS and in all the clouds is to use infrastructure as code, which in AWS means CloudFormation. In CloudFormation, you create these YAML files, and these YAML files are processed by AWS and create infrastructure you need. And there is people that doesn't quite like CloudFormation because these files can be very long. This is an example of a YAML file for CloudFormation. So you describe your infrastructure here, and it's a lot of text. To do all of this by hand, without syntax checking, without something that links the code, that validates that it's correct, it's hard. You can spend a lot of time making sure all of this is correct, that all the indentation matches, that all the strings are correct, that you don't have any typos and anything in these hundreds or thousands of lines. But this is the correct way of creating infrastructure in AWS. So the question is there something better, something that allows me to have syntax checking, to have a linter, to have guidelines, to have snippets of code? One solution is the CDK. CDK, it's to create a program in a language, in a programming language, that it's going to be compiled into CloudFormation. The result of my program is going to be this YAML file. And there is a version of the CDK for Python. So when you use CDK to create infrastructure, you use Python syntax in your program to say, I want a new bucket, and this is the variable for the bucket. There's going to be service S3, a new bucket with this name. Well, this identifier, this is going to be the name. It's going to be version true, and it's going to be configured as a static site server with this domain. And this instruction is going to create the CloudFormation template. And you can create your infrastructure with Python in a Python program. And you can have your program have for loops, while loops, if statements, and decides if it wants to create some infrastructure or not. This part has syntax checking. This part, we can have modules, we can have functions, we can encapsulate part of the infrastructure. Everything we hold dear and love about Python, we can have it here in CDK, with the tranquility that when we run our program, it's going to create these thousands of lines of CloudFormation, and these thousands of lines of CloudFormation are going to work, and it's going to work the first time. So I would recommend you very much to use this, to use CDK. It works very nice. It lets you create Lambda functions, tables, all kind of infrastructure in an easy way. Let me see if I can show you what I am talking about. But the good thing is we have time. This is something I created for a client. Perfect. I think there is only one problem. There's one problem with this example. I didn't thought it before. But the problem is that it's in TypeScript, it's not in Python. But okay, believe me, this works the same in Python. Basically, you create your infrastructure. I'm creating a code commit repository over here. This is the name, this is the description. An S3 bucket with this name, this removal policy, it's versioned, public access blocked, it's encrypted. I am adding tags to the S3 bucket. I am creating a DynamoDB table, which is this name, removal policy, billing mode, read capacity, encryption, partition key, and sort key for DynamoDB, for example. Another the secondary index for the table, the tag, and tags for all of the resources. All of the resources in this stack are going to have these tags. So I created this code, and as you can see, we have 70 lines of code in this case TypeScript, but could have been Python, just as simple of that. And when I compile this code, what I get is this. This is what I get. This is the CloudFormation code that generates everything I showed you. And as you can see, it's a lot of stuff. My 70 lines of code end up being the twice of that. And the good news is I can be sure that everything here works. Everything is correctly formatted. There are no close quotations or close parentheses missing. There are no quotes missing. All the values are correct. All are valid, and this works fine if I run it in CloudFormation. In fact, CDK lets me deploy automatically without needing me to do an extra step. So I would very much recommend you to do this workshop. In this workshop, there is an option for doing it in Python. It works perfectly fine in a free account and lets you check all the power that CDK gives you to create infrastructure. This is not to operate infrastructure, to operate your account, but just to create the infrastructure you need when you're going to put your workloads. And in Python, so it works great. I put the reference here. So I finished early today. I'm glad for it. I normally spend too much time. So if you have questions or comments, now it's the time. We have a time to some minutes to chill out.
Definitely. Yeah, if anybody has any questions, 100% feel free to ask them. The folks who are in here right now, please, yeah, go ahead. If you're not in here, use the Slido, and I'll be able to ask David those questions. It's funny you start mentioning the CDK. We have so we run the local indie AWS user group, right? And we have a guy who's pushing the CDK hard. He loves the CDK, and so shout out Ken Winter if you're watching. Shout out Ken. He's a big fan.
Good work, Ken. That's the idea. Yes, it's a game changer. CDK, it's very important. It's the future because CloudFormation, even if it works very good for what it does, it's hard to write. To write this by hand is really hard. To debug this is really hard because you don't have access to any of the tools we are used to. And the people that dominates CloudFormation is going to tell you this is a program, this is code.
Mm-hmm.
And some of us say, no, that's YAML, that's not code, that's a text file.
Right.
The big issue is you don't have a debug here, you don't have a linter here, you don't have any way to check this. You need to run it and see if it works or not. And with CDK, you do have all these facilities. You do have the ability to have conditional branching. That it's very hard in CloudFormation. You can do it, it's hard. You can do it here, and you can do for loops, and you can use the type checking and the syntax checking of or IDEs. So I believe this is the future of CloudFormation, to use CDK for infrastructure. Unless your application is very serverless, there is the SAM framework. It works great for serverless. I would say for some very specific time of project, SAM is better than CDK, but for the rest, CDK is much better than trying to do CloudFormation by hand. So I'm with your friend. Yes, CDK is the future.
Yeah, I agree. Yeah, it definitely makes sense to me. Just makes it like just the workflow process just so much simpler and I guess intuitive. I guess, right?
We are
Um,
used to do it, and some people would say the part of the charm of infrastructure as code is to be declarative. When I do this in CloudFormation, we are declaring the desired state. We say, this is what I want, and I don't care how I'm going to get there. Remember, I told you this program I built that read from a file and created the instances. The big issue there, my big mistake, is that it was imperative. If I try to run the program again with the same file, it's going to fail because the instances already existed. So it was limited in that part. It was imperative instead of declarative. The good thing about CDK is that it's both. Even if my code is imperative, the result is the CloudFormation template that it's declarative. So we have the best of both worlds. We have a program that has the logic we are used to in Python, but the result is a declarative CloudFormation template that it's idempotent. If I run it again, it only checks that my infrastructure meets or it's the desired state. It does what I want. It doesn't create the instances again, for example. So it works very nice, this CDK. I recommend it to you very much.
definitely.
And I'm at your service if you want, if you have any questions in the future, you can find me on Twitter and send me a direct message there. As I told you, all of this notebook, you can find it in this repository. I want to thank you for the opportunity. I love doing this. And thank you very much for letting me do this.